All right, I'll be here. I guess I should stay. All right, so we have one little bit left over from the lines section. And it's really, well, let's just see what you guys think. Let's do this. Let's start off with a, whoa, not a weird echo right there. Let's start off with a review of something we did last time, because it's going to become very important immediately. Can you guys find the equation of the line that goes through, oh, somebody's logged in the computer. I wonder who it is. It's not me. Through, let's start off nice. 4, -1, and -3, 0. That's not nice, Jeff. 0, -3, there we go. That's nice. So, do that problem. Yes, and don't do it on your phones. So your phone should be gone. Do that problem for me. Find the equation of the line through those 2 points. As much as you can get done. If you're not sure how to get it, do as much as you can. And I told you about this thing, right? Yeah. All right. I don't like it. It's too bad. Oh, yeah. You get used to it, or you can hate it as much as you want to. But I don't even think about it. It's just the way I see equation. Two, 4, 6, 8. Do we appreciate? Okay. Just to make sure everybody's on the right track. Yes. Sorry. Yeah, of course. Oh wait, no. What do you mean? Are those corrections you got back? You only correct things once. Yeah. It's not English class. There's no first draft, second draft of your corrections. So that's why I said, guys, real quick, that's why I said don't turn it in until somebody's looked at it, especially me. If I tell you it looks great and it doesn't, I'm going to give you the benefit of the doubt because that's my mistake. You guys with me? So if you have me look it over.
I didn't know I could do that.
Did I tell you guys that? No. Yes? Yes. So before you turn in any corrections, you can just say, hey, do these look okay? And I'll tell you which ones don't.
Okay.
Isn't that crazy? Yeah. I'll even help you if I got time.
Okay.
Can you guys remind me what's the equations of a line? What's one of them?
Am I supposed to?
Kick ass. You want to start with that one? And then what's the other one?
Y minus y 1.
M parenthesis x minus x subscript.
Yeah, cool. So real quick, does anybody, I can't remember, does anyone play guitar? Has anyone ever seen a guitar?
Mm-hmm.
Okay. You know that you can plug them in these things called amps, right? Okay. You can control the volumes of the turn. Okay. I always think about slope as an amplifier. So let me see if you guys are cool with this. X minus x1, doesn't that tell you how much x changed? So if the slope is, stay with me now, if the slope is 2, that means the y's will change twice as much as the x's did. Do you guys see that?
Say that again?
If the slope was 2, however much the x's changed, the y's will change twice that. It's m times this. So if m was 1/2, the y's are going to change slower. I'm going to go up slower. You guys kind of with me? So I always think of slope as kind of like an amplifier. Now the amplifier could be fractional, so it actually makes it softer, makes it not go up as steeply. Are you guys at all with me? Maybe? Okay. Same thing happens up here. If I change x, y changes by that much, and this is where it starts. So I always think of a slope like a amplifier of x's changes. Okay. Which equation can I use directly for the given problem?
The first one?
I could use this one, why?
Well, it gives you the y-intercept already.
Yeah, so what's b?
-3.
That's insane. So then all I have to figure out now is slope. And how do I figure out slope?
y2 minus y1.
Sorry. Thank you. I liked how it was in stereo and like equally enthusiastic. Y2 minus y1. Yeah, it's that shit, Jeff. I don't blame you. I'm not trying to say this is exciting. I'm not. Even though I geek out over every level of mathematics, it doesn't have to be exciting to everybody. It doesn't, remember guys, it doesn't matter which one of these you call y2 or whatever, you just have to subtract in the same way. So if I do -3 minus -1, and that's the biggest mistake I see. -3 minus, and then this is negative itself. Your brain just says, all right, put a negative. No, that's from the freaking formula. If the point itself is negative, it's got to have another negative. And like you said, that would become a plus. And on the bottom, I'm going to have 0 minus 4. I've got to go that same way. If I do this minus this, I got to do this minus that. Kick ass. What's -3 plus 1? That's insane. 0 minus 4. So what is my line equation? People sometimes get here and stop because they feel like they've done enough work. You're not done yet. Y equals
1/2 x.
1/2 x minus 3. Bam! Kick ass. So when you get the y-intercept, that desperately kicks ass because you already know what b is. All you got to do is get m. You're done. Just put it together. How's everybody doing? Do you understand it? Do you understand? I could give you points that would make things look worse. Do you know what I mean? Like one point I could give you is 11.1 comma -28.73, and another, you know what I'm saying? On one level, I understand if you tense up a little bit, but on another level, does any of the process change? It doesn't change for shit. Yes? I need you to see that. So I used to always say, math doesn't care about what you're doing stuff to. The process stays the same. Humans, we care about what we have to do with the shit, right? If I gotta subtract freaky ass numbers, I'm gonna freak out, but this process doesn't change. All right. So what if I wanted to find the equation going through 11, -5, and 6. What you got, Jeff? I don't know, man. 10, sure. Okay. So, I mean, I can't remember if I officially showed you how you could still use mx plus b, but on one level, why would a teacher or student possibly say you shouldn't use mx plus b?
You're not giving B right away.
Exactly. I'm not giving b right away. Some of you guys might know, so I try to start with y minus y1 because you guys are all in this class because you're going to take calculus next. And that equation becomes really crazy important pretty soon into calculus. So I need to kind of keep that alive. Yes? But I will, so we're going to do this problem with y minus y1, blah, 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 blah. And then I'll show you how to do it with y equals mx plus b because you should know how to do it if you don't know. And it kind of, some of you guys have never seen it. You know, how the hell would I do it? I don't know what b is. Okay, we're going to find out. So does the process care? I've got 2 different points, and neither one of them is a y-intercept, so I don't know what b is. What 2 things do I need to still figure out? Slope and a point. We got 2 points, so we're settled with the point. Yes? So you can pick whichever point you want to. Go ahead and figure out the slope real quick. Let me give some stuff else back here. Hey. How's the slope come in? Try to make it not too evil. 15 over a -5, so it's -3. Kick ass. I like it. Just be right. I mean, the slope doesn't have to be a nice round number, so you know, it could come out fractional. So, first way I want to do this is this way. We know what m is? Sorry? Yes. -3. So I know what I'm going to put there. Now this is a choice you guys can make. So does anyone want to choose this one?
No.
Anybody? I like David's like, I'm going to answer a question you didn't ask, Jeff. Does anyone want to use this one? Nobody wants to use this one?
I think I use that one.
I'll use that one. Anybody else wants to?
No.
All right, Damien, use this one.
All right.
And then everybody else use this one.
Cool.
You guys with me? Does everybody understand what's happening? How does that mean? What do I mean use this one? What does that mean? What do I put here?
10.
Yes, I put the y piece there, and there I put the x piece. So you guys do 610. And I think it's the negative that freaks you guys out, I would say, maybe. I don't blame you, man. I don't care how good at math you are, negatives find a way to screw you over. So you should have what here if you're using this point? Like you said, you have a 10 there, and what do you have here? 6, kick ass. So I'm purposefully, I want to show you, it doesn't matter which point you use. How many points are in a line? Be more specific. Or weirdly less specific and more specific at the same time. How many points are in a line? Infinite. And it shouldn't matter which one I use, because they all live on the same line, they all are governed by the same equation. So if I do this, I get y plus 5, distribute, subtract 5, I get negative 3x plus 28. Now, if you use 610, did you end up in the same place? Mm-hmm. It didn't look the same here, did it? It didn't look the same here either, but then at the end it looks the same. So it's got to, and it should make sense, because it's supposed to represent what governs what points live on this line. And there's an infinite number of them, so who cares which one I use? I can use any of them and get the exact same equation. Okay, so I made a semi-big deal, and in fact, some teachers make too big of a deal out of the fact that we don't know the y-intercept, and therefore mx plus b, how do you use it if you don't know b? Yes? Well, we're going to somehow do it anyway. So just to remind you guys, I have this point, and we know the slope is negative 3. And I'm going to use this equation. Because I'm just a rebel. Don't live by anybody's this. Watch out, Jeff's going crazy. So this equation, what do these represent? Any points on the line. If I change the point I'm looking at, can B change? If I have a line, and I just look at a different point, can B change? No, if I have a line and I'm looking at a point, there's no way it's going to like suddenly hit the y-axis somewhere else. You with me? So what do I actually know that goes in this equation? I know m, and I know 2 sets of x's and y's, yes? So again, you could use whatever you want to. So if I use this one, 10 equals negative 3 times 6 plus b, 10 equals negative 18 plus b, add 18, does this look familiar? Yeah. So how many guys knew this little shortcut? Does that look familiar to anybody? You guys? Okay. And the same damn thing if you plug in 11 negative 5. It'll look different until the end, and then it'll be 28, just out of nowhere. Okay. If this was, where did I put the other? There it is. If this was the equation that represented how many mistakes somebody makes on a quiz given a certain number of hours studied. Are you with me? Given a certain amount of hours studied, this represents the number of mistakes they would make on a quiz. Are you guys at all with me? So if somebody studied for 2 hours, negative 3 times 2 is negative 6 plus 20 is 22. Somebody studied for 5 hours, negative 3 times 5 is negative 15 plus 28 is 13 mistakes. You guys with me? Now listen, this equation is not real, but it does kind of make sense. The more you study on average, the less mistakes you should make on average. Yes? There is an equation that actually exists for different situations that models. Is everybody sort of with me? I'm trying to get us in the mindset of what we're about to get into. Linear functions are really simple. Most things in the real world aren't, but there's a ton of shit that is linear. Has anyone ever called a plumber, or has anyone ever taken an Uber somewhere? All right, there's an equation that governs how much money you're gonna have to pay that person depending on how long you're in the damn car. Yes, you with me? You with me? Okay. How many of you guys have never been in an Uber? Never been to Uber Java? No? Okay. I was just really happy they had Uber up in Nova Scotia that helped me out a few times. Okay. So if this equation modeled how many mistakes you're going to make based on how many hours you studied, what if I studied 0 hours? How many mistakes would I make? 20. I would predict somebody would make 20 mistakes on this quiz. Yes. And you can see that from, the y-intercept that we get eventually. Yes? Okay. So we're about to get into situations where, let me kind of go with it by, what do I need to give you? What is the most basic thing I can give you so you can get the equation of a line? What is that I kept giving in the 2 problems we've done so far? 2 points. So if I'm given a bunch of information and they say, find the equation of the line that models this situation, you change your whole perspective to, what points did they tell me? They're not going to list it like this. They're going to say, if you have 6 boxes, then it weighs 10 pounds or whatever. You guys with me? It's not going to look like a point, but you're going to go, oh shit, if I write that's a point. Boxes, comma, pounds. You guys kind of follow, okay? Okay. So, again, I have some copies of, well, no, I don't. I have copies of Module 3. I don't have any copies of Module 2. We just have a little bit at the end. Was it 2? Or was it 4? It was 2, yes. So screw that one. I'll think about it. Okay. Let's look at this. You can tell this was written by some math teachers. Very creative. Sugar Sweet Company. It's going to transport its sugar to market. It costs $4,500 just to rent a truck. Yes? It's a big ass truck. And it costs an additional $225 for each ton of sugar transported. Okay. We can make it, now I want you to realize, the level of math we're at right now can model very basic situations. And there are situations in the real world that would have been modeled. What other variables might happen in the real world, though, that's not coming into play here? All right, I got you. But that would affect my cost. That's not something serendipitous, or in this case, like anti-serendipitous. Say again? Units, gas. The units they give to us, thankfully. Yes? What else affects how much money if you rent a car or rent a truck? Besides the amount of stuff you put into it and the cost to rent it. Okay, the time, you've got it, yes. If you have it for 2 days versus 3, it's going to cost. Also, what about miles, which could translate into gas, but still, mileage. They very often charge you for mileage. Okay. I say this just so you know, any problem we do has been sort of boiled down to a very straightforward kind of like analyzing 2 variables at once. As you go further in mathematics, you can start to handle more variables thrown into an equation, yes? And then it starts to become closer and closer to like everyday real life. Okay. Let's C represent blah, 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 blah. Okay, now this one's a little more straightforward than what I was saying earlier. It didn't give me 2 points, but it's a lot more straightforward. If I just told you m is 2 and b is -3, can you write the equation of the line? Shit, yeah. If I said the slope is 7 and the y-intercept is 0, 4, could you write the equation of the line? You know what b is, you know what m is, of course. So can somebody tell me, what is the slope?
225.
Totally. Why is that the slope?
This is for each ton of sugar, so.
Say again?
It's for each ton
Yes.
of sugar, so.
So a key word is like per mile, or in this case, for each. It's like, I could have said 225 per ton of sugar, right? So doesn't that depend on how much sugar I put in? What's the fixed cost?
4,500.
What? So that would be, sorry. That's the part of the equation that is not affected by the variable. So the y-intercept, does it ever change? No. As I change the x variable, whatever the input is, then my output changes. But the y-intercept remains the same. Okay. So fixed cost, $4,500. I don't give a shit if we turn around and give it back to them. It costs $4,500 just to get into the truck. Yes? So that's fixed cost. So I want to use something in this form, but what am I going to replace x with and y with? Yes. So the cost is a function of the tons of sugar. S is a bad choice for me. Very few letters are a great choice, but S is a bad choice. Here's S and here's 5. So I'm going to use T for tons. T, I think, is a little bit better for me. So what did we figure out already? The M was 225. The fixed cost, so the amount, if I have 0 tons, the amount just to get the truck empty is 4,500. So now we have an equation that models how much it costs. And then I can say, okay, I need to put 80 tons of sugar in this damn thing. I have no idea what 80 tons of sugar looks like. You know what I mean? How big that would be, huh? Would it fill the room? I don't know. Hey, it does. Are you guys semi-cool with this? You guys see this? So this kind of problem has a lot of words, but it is barely a word problem. Because they just told us the slope and they told us the line, so you just have to interpret what they're talking about. So let me show you a little more involved problem. Oh, the very next one. Read through example 11. If you guys have ever bought a new or used car, you understand the minute you get into the damn thing. Yeah. Trying to figure out the emotions of this thing. It looks concerned, actually. Okay. So, has everybody read through this? You guys have read through it?
Yes.
Okay. I want my input to be what? Which variable is my input? T, good. And it kind of gives it away here. Right? So it's the value as a function of time. So I want time to be the input. So time is going to act like X. And of course that means my value is the output, the Y. Okay. Do you guys see 2 points that they gave us? Again, they didn't give us as points. They gave us as information. What would a point look like? What did I just say is the X variable, the input? Time. So it would be time, comma, value. Yes?
Mm-hmm.
Notice how they define T. How did they define T? And I'm pretty sure we talked about this before in terms of we have control, we can call it. Yeah. They made it smart, right? They're like years since 2018 because that's when everything starts in the problem. So what point is in the first sentence? What point did they actually give us?
0, 34,000.
Exactly, 0, comma, 34,000. When you have big ass numbers and a point, that kind of sucks because then you have a bunch of commas and you get a little lost sometimes. So, see if you can get away without doing the commas. And then what's the other? What is there another point? No, I'm being silly. Darn it! It isn't the kind of problem I wanted it to be. That's okay. What is the other piece of information they give me? It's still not as interesting a problem as I wanted. Here's where you got to be a little careful. What's the slope? Because we know what now.
Is it negative with 100?
Yeah. Good. I love it. All right. Okay. Slope is going to be, it depreciates. It loses value, $2,500 each year. So it's got to be negative 2,500. Yes, because it's going down. It would be great if it went up. That'd be amazing. Getting a new car would be great. Trade it in. You owe me money. I'll take that car. Thanks. It don't work that way. So we know B, and we know M is negative 2,500. So then, of course, how do I write this function? So now, it's y equals mx plus b. So v of t, what's the slope? And I'm going to put in place of x, I'm going to put t plus 34,000. And once you have the function, you can answer any question they ask. What do we know about the year 2024 in terms of what this function needs? How did we build that function? Can I put 2024 in for t?
6.
You plug t in, yeah. If you plug 2024 in, you've just done 2018 plus 2024. You're in the year 4042. And your car's probably not doing well. It's probably become several other cars since. Yes? So yeah, this would be t equals 6. You throw a 6 in, go to town. Yes? Yeah. And then how would you do part C? What's different with, so real quick, I'm sorry. If I did plug a 6 in, you just have to plug a 6 in like we did with other functions, and then you figure out what this is.
And you said equal to 9,000?
Do it again.
The last one that you're asking about?
Sorry. Let's do this one real quick. I kind of bypassed it, just to make sure everybody's on the same page. 6 years later. Every year it goes down 2,500, so the math makes sense. 6 of these. 2 of these is 5,000. So 6 of these would be 3 times that, so negative 15,000 plus 34,000. Check my math, you never know. 34 minus 15, 19, yes. So the car in 6 years would be worth $19,000. So much. Now, how would you do part C? That's the one now.
I said equal to 9,000.
So what equal to 9,000?
Like instead of like V, 9,000.
Kick ass. So I want the value to be 9,000. So I'm going to replace V with 9,000. And it says what year, so we do not know what the year is. What year is it? Go. I was worried. I was hoping that then. But you actually woke up. How do you solve that? Take a minute, solve that for T. Let me give Kelvin back. Oh, no. Yeah. Let me get my glasses. Okay, right here. So you're supposed to subtract this. You were just subtracting half of it. You have to subtract the entire f of x. That makes sense? So real quick, 8 minus 5, that's all. Anyway, that's 3. But isn't 5 3 plus 2? But if I do that, that's 5 plus 2, that's 7. So what I mean is this. I want to subtract the whole number. So if I want to subtract f, and it's got 2 parts, I got to put both parts in parentheses. Negative. You see how that's going to make this? You need everything without an h to cancel. Yeah. And that, of course, becomes the whole limit thing in calculus, right? Yeah. We're all going to sound like prophets. In the year 2028, your car will be worth shit.
Time traveler.
So if I subtract 34,000.
What if I scam people and use the equation and say I'm a time traveler and I know the value of their car by this year?
Try it out. Let me know how it goes. Is that cool?
If it works, we're all gonna be rich.
Basically, the shortcut for solving linear functions is wherever your variable is, get that term by itself first. So I want to move that thing out of the way, and then you almost always divide last. So then I'm going to divide by negative 2,500. Negatives cancel. 25 divided by 1. 2 zeros cancel, so what do I get? 10. Now, of course, the right answer is going to be a year. So like Damien said, what year did we start in? 2018 plus 10 is 2028. Cool. Okay. All right, so let's do one that's slightly more interesting. We actually look at it, make sure. Damn it. It's not very interesting at all. There we go, perfect. It's perfect. All right, you're gonna love it. You're gonna love this. So guys,
Yes.
when you're trying to find linear model, and all it means is a function that models the situation we're looking at. Okay. Either they're going to give you straight up the slope and with a point, just like the last two here. In this case, they give me two different times. So I'm given two different points. You have to stop and say to yourself, okay, when I set up a point, I got to make sure that the input is the right input and the output is the right output. Yes. What variable is supposed to be the input? And you can look at part A to help you out. The hours. So you gotta be careful. It isn't necessarily the first information they give me is kind of like the first piece of the point. It depends on how we want to set the function up. I want height to be a function of time. Kind of makes sense because I'm like, after 10 minutes, or 10 whatever, how much of the candle will have burnt down? You know, that's what I want to know. I want the input to be time. So it is the order they give me. So can you find the 2 points? Let's start there. Take a minute, see if you can write the information they've given us as 2 points.
Yes, of course.
Thank you. I never have to wonder. I know exactly what's going on. I appreciate that.
I got you, Jeff. That's what I'm here for.
I'm gonna write this day down on my journal. So what do you guys get? What are your 2 points?
11,
11?
18.8,
18.8,
and 27, 15.6.
27, 15.6.
Yes, Jeff. Let's go.
That's my line. And so this is exactly what I was saying earlier. Worse looking numbers, but the process doesn't care.
That's right.
I remember one time I said that in the class and a student said, that's right, they don't care about me. I'm like, all right. The process don't care about what the numbers are. We do, because we're the ones that have to work with it, but the process is the same. You find the slope, is it gonna be pretty? I don't know, we're gonna find out. It looks like it probably won't be. And then you find a point. You got 2 points for the big one. All right. So try to do the y minus y1 equation. And what I tell students is there's nothing wrong with starting with y and x. Not a damn thing wrong with that, as long as at the end you replace them with the variables that are appropriate for this problem. So when I'm doing my work, it doesn't matter how I'm representing shit to myself. At the end, I better represent it as H and T. But in the middle, I'm gonna call them freaking Y and X because that's what I'm used to. I personally don't see a damn thing wrong with that. Okay. If you do,
You
great.
tell them, Jeff.
Yeah. That's me out on the street corner. I don't care what variables you use, do it. I don't, man. So I gotta figure out the slope first, right? So let me catch up to you guys a little bit. Let's see. Oh, that's not too bad. So if decimals freak you out, what's 32 divided by 16? 2. So what's 13? That was 3.2 divided by 16. 0.2. And if you really wanted to, what is 0.2 as a fraction? Is everybody cool with what I just did?
No.
Are you serious? All right.
Yeah.
What's okay? I'm sorry, David. This is the trouble with like joking all the time because I don't know when you're being serious.
For real.
I have the same issue sometimes. But 32 divided by 16 is 2.
Okay.
If I cut the thing of dividing by tens, the answer is going to be cut by 10. So I actually just moved the decimal. So if I had 0.32 divided by 16, it'd be 0.02. I could start with 2, walk it back twice, 0.02. You guys with me at all? That is one really nice thing about decimals. Does anyone know what 0.2 is a fraction? I love it. It's 2/10, 1/5. And that sounds more like a freaking slope. Yes? Rise or run? Not a damn thing wrong with when it makes sense, changing a decimal into a fraction. When won't it make sense? Well, if the freaking decimal doesn't stop. Then don't do that shit. And by the way, I'll show you. Maybe we'll get one like it later, but now we got the slope. Now use this and finish it out. And you can see the authors of the book have given you so much room to work with. It's our first attempt, so we'll be revising this, I think. Oh, we're back on there. This doesn't look at all.
No, sorry, I did that too.
You're fine. All right, that sounds. Yeah, that's fine.
So what I could pull out more.
I see. Oh, okay, you brought that in there. Yeah, that was good. What do you mean pull out more? Oh, it wouldn't do anything for you.
Right.
Yeah. Yep.
So that's right now.
Yep. Totally. All right, let me catch up. And again, it doesn't matter which one you pick. I'm gonna pick the first one. Why not?
Wrong.
Hmm?
Wrong.
Wrong.
H and T.
Oh, I'm not done yet.
Alright. Making sure.
Excuse me.
Just making
I
sure.
appreciate you checking. Had to check myself before I. Let's see. So if I distribute, you get negative x over 5 plus 11/5. That sounds exciting.
I thought
You
it was
guys
done.
Huh? What was 9? What's up? Is that right?
I have to do more? I
Yeah,
just go
dude.
like H and T and then that was that.
Oh, I see what you mean. Solve for y. Always get y by itself. And then I want to add 18.8. Let me write this more like that. Now, to combine those things. Alright, so everybody semi with me.
So you're taking it from point slope to y equals mx plus b?
Totally.
Okay.
Do you guys agree that if I can give you the same information in a more compact form, that's better? So y minus y1, blah, 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 that's like a starting point. You always solve for y, get it into mx plus b form. Because very often the y-intercept is incredibly useful information. It's the beginning for a lot of problems. That's t equals 0 is the y-intercept. Does that make any sense? So if I can see what the y-intercept is just by looking at an equation, that's a lot of information to give somebody without even doing any work. To combine those, there's 2 ways I could do this. I could either convert 11/5 into a decimal, or I can convert 18.8 into a fraction, yes? So this will be 11/5 plus 18 and 8/10, which is 11/5 plus 18 and 4/5. How you guys doing? Everybody excited? Okay. Which is 18 and 15/5. Yes? You guys with me? I need you with me.
Yeah.
What's wrong with that? Now, there's something wrong with this. Yes, the way I've written it, but mathematically there's not a damn thing wrong. Because what do I have here? I have 11/5 and 4/5 is what? 15/5. And I have 18. Do I have all that shit here? Well, what is 15/5? 3. So what is this? 21. So what was the original height of the candle? 21 centimeters. 21 centimeters. Now, I don't know how much, I don't have a lot of candles, right? I'm not a candle person. I have candles in my house because it's a holdover from back in the day when we would lose power all the time when I was a little kid. And so we always had candles and flashlights. And the flashlights, the batteries are almost dead, so we always make sure to have candles. And then we just put a candle in every room, and as a little kid, that was exciting. And then I was in Florida, so hurricanes happen, and then power would go out, and you want something, and the stupid flashlight batteries are always dead because you always forget to, so you have a candle, right? All right. There are candles that they actually know the burn time, so you can use them to time things, sort of like an hourglass in the same way. Okay. So if I knew how long it took for this candle, a candle would represent a certain amount of time. So if I started it burning, it would actually measure a certain amount of time for myself. If my egg timer wasn't working or whatever the shit. Yes? Okay. What does the slope represent here? Remind me of the slope. What's the slope?
10.
What was the slope?
-1/5.
-1/5. What? And isn't slope rise over run? Change in the outputs divided by change in the inputs. What were my outputs in this problem? And now, Damien, you should be yelling at me. What should I do down here? Why is this not the answer yet?
H of t?
Yes. So I'll pretend like your earlier yelling at me happened right there.
Alright, wrong.
Okay. So the slope, I really want you guys with me on this. Slope is change in outputs divided by change in inputs. What are my outputs physically? No, I know it's an H. Height of candle. So my output is centimeters, and my input is hours. If you just remember, slope is outputs divided by inputs, and you just put the units for each, top and bottom, you have an interpretation. How do I interpret this? Beautiful. So it will go down 1 centimeter every 5 hours. You with me? That's got to be a thick ass candle. Because I mean, they go down quicker than that, if I remember correctly. 1 centimeter in 5 hours. That's a slow moving candle. Okay. What's another way to look at this? You could also say it goes down 1/5 of a centimeter every hour. Do you guys see that? Okay, kick ass. And of course, this kind of question becomes easy because we have the equation. I can look at this as a pure math thing. Where would I put 23?
For T.
In for T, yeah. And then whatever the hell that is. It's 26, so it's 5.2, negative 5.2 is 15, no. Yeah, 15.8.
16.4.
Did I go the wrong
That's
way?
right on.
Is it 16? What did I do? Oh, I did 28. What the shit's wrong with me? Let me do it. 26, negative 2.6. 5.2. Wait, help me out.
You put 13 at 23.
Oh, I put 13. I'm so awesome.
That would screw anybody up.
Yeah, using the wrong number normally does.
Can happen.
All right, let me see if I can do my shit now. Let's see. This will be 4.6, so it'll be, it goes down 4.6, so that'll be 16.5. Is that right? No. 4. Yes, okay. 16.4 centimeters after 23 hours. The more interesting question would have been, how long until the candle is gone? That would have been a more interesting question. How would you do that question? Part E. How long until a candle is a puddle of wax? That's what that says, by the way. This is Jeffish, and in English, this is how long until candle is a puddle of wax.
So equal to 0.
Yes, the whole height's 21. So you want the height. Yeah, you want the height to be what?
0.
0. Not 23, Jeff. No, I'm stuck on 23. How would I solve that?
You just solve for X.
Yeah, solve for t. So you would subtract 21, multiply by negative 5, right? So you end up with this candle somehow lasts 105 hours. That, my friends, is a candle and a half. That's all right. That's one of those candles that are like, wow, wow, little wicked little. All right. Enough of that. So the problems in the book, I remember I at least assigned one population problem. So these are really classic problems. And what's funny about them, so for example, let's say some town was founded in 1910 and it started off with 500 people, and then in 1970 it had 100,000 people. You know, find a linear equation. The really dumb thing about that is, I hope some of you guys know, what does population growth look like? Does anyone know population growth? Does it look, yeah, beautiful, it's exponential. Because the more people you make, the more people there are to make more people. So it kind of feeds on itself, and it ends up looking like an exponential. That actually, if you get far enough in mathematics, you actually start with, what is population? The change in population is related to the amount of population you have currently. If you get to a higher enough mathematics, you could do the math from what I just said and end up at an exponential. All that shit aside, if you do see that problem in the book, you're assuming this town for some reason has linear growth, which means terrible things, because these townsfolk are dying for some reason to kind of make the curve linear. Weird things are happening in this town. I don't know. Things are happening. Okay. So, here's what we're about to get into. What I want to do with the rest of the time. So factoring is coming back. And hopefully I made it really clear that factoring is something that just is going to crop up wherever the hell it wants to. So you have got to, and this is not just this class, this is every damn STEM class you could take after pre-calculus, after this class, yes? Factoring is just a fact of life for people studying rates of change of things, and what science is that? All of them. So factoring just happens. And that's why it's always funny when I'm first teaching factoring to students now, like, when the hell am I going to use it? Oh, it's not, you just don't know enough math yet to see all the crazy stuff you can do. Now, I want to kind of step through each of these methods. Does any of this sound familiar? I mean, you all know what square root is, but you might not know what square root method means, right? It's not some get-rich-quick square root method for making money on the stock market. Completing the square, does that sound familiar to anybody?
Yeah.
And I don't mean I start drawing a square and you guys quadratic formula, obviously. Does anybody know the quadratic formula? There's a song that we had forced it to. All right, I don't want to hear about it. Keep it to yourself. All right, so let's do this. I want to start going off script here. I'm going to ask you a really silly question. If I have two numbers, and I don't know what the numbers are, two numbers, yes? And they multiply to be 8. Do I know anything about either of the numbers?
Nope.
They got to multiply 8. That's all I know. So is there anything that either number could not be? It could be negative. It could be negative all day. -4 is -2. There you go. Neither one could be 0, right? But what could they be? Almost anything. You with me? And if you don't know what I mean, you're like 4 times 2 and 8 times 1. Well, what about 800 and 1 over 100? I mean, once you start going there, everything just freaking opens. Yes? That's amazing, Jeff. So what if you have two numbers that multiply to be 0? What must be true? One of them's got to be 0. So if I have two things multiplying and they equal 8, that sucks. I can't say shit. If I have two things multiplying and it equals 0, I know that one of the two has to be 0, at least, if not both. You're all like, that's great, Jeff. Good job. So let me ask you this then. What if I had x plus 1 times x minus 2 equals 0? Do I have two numbers multiplying? I totally do. If I knew what x was, those are two numbers. Some of you guys should be able to see the answers. So, in order for this statement to be true, one of those two has to be 0. So then you just say to yourself what I just said. Either this one is 0, or this one is 0. You have taken what would be a quadratic. So do you understand what step would have been before this? Before this, we would have factored the damn thing, yes? So it would have started here, we factor it. You with me? So that's kind of like the missing step that's going to come in for you guys. Yay! You set each piece equal to 0, so you've taken one second-degree equation and made it into two first-degree equations. That's the trade-off, and that's a trade-off we can all live with. I'm like, give me, I don't care, I mean, leave fun, and blah, 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 blah. What's the answer? -1 or 2? Okay, so if you plug either one of those in, it makes the whole thing 0. Now, just to really hammer this home, is everybody with me so far? Roughly? Okay. What if I had this? X plus 1, I forgot what I just had, it doesn't matter, Jeff. X plus 1 times x minus 2 is 10. You might be able to guess your way to one answer. You might be able to guess your way to two answers, but that's just because I made this one nice. How can you make sure you get the answer? Can you just say x plus 1 is 10 or x minus 2 is 10? If you have two numbers that multiply by 10, does either one have to be 10? Does either one have to be anything specific? The only thing we know for sure is neither one of those two numbers is 0. Because then it would multiply by 0. Is everybody with me? What number do you wish was there? 0. Of course, this is the thing that a lot of students just sort of miss. If it's equal to 0, then I can set each factor equal to 0, because then I know something. One of them has to be 0. If it's equal to anything not 0, they could be any freaking thing. It could be anything. So, what the shit do I have to do? This is like somebody factored too early, and we're like, God damn it. Do you guys see what I mean? They factored too early. Because what did they not make it equal to first? They didn't make it equal to 0. So what do we have to do? What do we have to do to clean this up?
We have to put it into quadratic formula.
No.
Put it back together.
Put it back together. multiply it back out.
Yes.
Then what'd you say?
That's what I meant.
Oh, you have to put it back into quadratic form.
Yes.
Oh, I thought you were going to say formula, and that made me,
Or
okay.
math.
Gotcha.
My bad.
Quadratic format. Okay. So many words start with form. Okay. So if I multiply this out, I already did this on the other side. What did I get? X squared minus x minus 2. Let's see if Jeff made a problem that works. Then what do I do? What do I do? Subtract 10. All right, I'll wait. You guys finish it up. You guys finish that? Your brain has done it? I teach a class, math for elementary teachers, and I wish I'd been able to teach this forever, but I only last 4 years started teaching. And we watch videos of little people working with mathematics from kindergarten up through 9th grade. I'll never forget this one little kid. He does this problem, and the guy says to him, "How did you do that?" And the kid goes, "I thought about it, and then I said 4." That's so beautiful. It's like, show your work, kid. It's up here. So, this is now like a number problem, right? This is a number puzzle. What two numbers multiply to be -12, add to be -1 is what we're asking ourselves, right? Because what's x squared? So the only thing I don't know is what numbers make this work. And of course, what numbers make it work? Yeah, -4 and 3. And then, of course, then you get okay, so you get x minus 4 has to be 0, or x plus 3 has to be 0, right? Once you get two factors or more multiplied to 0, one of them has to be. So either this one is, or that one is. So x is 4, or x is -3.
You just put the sign on the middle.
Say again?
Like you can just look at the
Exactly.
and then just flip the sign.
Kick ass. If it's x plus or minus something, it's that simple. Just flip the sign of the dumb thing, yes?
Mm-hmm.
You gotta be a little more careful if it's like 4x plus 7, because then you're dividing and shit, yes? How does everybody feel so far? Does this sound familiar to some stuff you guys have done in the past? Okay. If you can factor, that's the best way to do these problems. Everybody goes to quadratic, because then, how do I say this? Then you just plug shit in. You don't have to really think about it much. You just plug shit in, put it in your calculator, yes? Factor when you can. You got to get practice with that. Okay. So that's great for this kind of problem. What if I have? Actually, let me do this. Yeah. Okay. Let's do this. So if you need a copy of this, I do have copies. Does anyone need a copy of Module 3? Has everybody got their book? Okay, that's awesome. I'm gonna cry later about that. Little happy tears. Try to keep my emotions to myself in the middle. I want you to do A, and I want you to do C, and I want you to not worry about the graph yet. Just focus on doing the problem. Everybody trips out about A. Does anyone remember the first thing you try when you're factoring? It's the first thing you try. Step 0 on my handout. GCF, yes, okay. That'll save your ass. People do all the weirdest things with problem A, but it's just GCF, so go for it. Do A and C. Maria and I are here to help if you need. Some of you guys might be realizing that factoring just live in the earlier section. So if it's true that you're still not that great with factoring, just come see me, we can focus on that. What do they both have? So take an X out in front. Yeah, so now, yeah, 2, 1, and this one, yeah, was it equal 0? So do you have two numbers equal 0? Multiply? You have two numbers, right? One is X times this one. So either this is 0 or that's 0. So the minute you have a number times another number, maybe times other ones, you can just take each one individually, set it equal to 0. Because the only way to make two things multiply by 0 is if one of them is 0, right? So either that first being 0, and that's an answer, or the second being 0. And then you solve that. So underneath you're going to put X equals 0. That's this dude. Or X minus 6 equals 0. And that leads to two answers. Good. Yeah. Well, wait, what's that one say? Is that plus?
Yes.
Okay, good. Okay. Remember to take my glasses with me all the time. Where are they? There. No, you're fine. Yeah. A little comma means over. It's all good. Right, that looks right. Looks right, curious. I do see. Okay. This is like the first level of what factoring is good for. Right? So when we teach students how to factor, understandably a lot of students are like, what the shit would I need this for? Then we do this. And then they're still like, what the shit would I need that for? But this is such a fundamental thing. It happens all the time. In every frickin' field, we want to set a function equal to 0. Because we want to see where things kind of start. We want to know what the max and min outputs are, for example. We're going to start with something. When is it 0? I don't blame you. You're trying to make it look like more like the other ones, but this is just GCF. What comes out of both of these? What do they both have? Yes. So over here, you're taking X out, and you would put parentheses what's left. Right? So maybe erase this. Yeah. I don't blame you. You're trying to make it look more like the ones we did. This one's a little more basic, so it's really easy to say what's hard enough. Yeah, yeah, equals. And now I got one number times another number is 0. So either the first number is 0 or the second number. So write that either X is 0 or X minus 6. So equals 0 or X minus 6 equals 0. So see, this is one answer already. Solve this for the other answer. You're done. Yeah.
Feel like C doesn't look right.
You.
Wow. Yeah.
Dude. Wow. That escalated.
It's the first thing that came to my head.
So this is the huge deal I was trying to. Just because two things are multiplied
I just thought
doesn't
about
mean you
it.
know that's the key. Right?
I don't know what happened.
It has to be 0. So the very first thing you want to do is what? Yeah. So you have a little cleanup to do before you start. Exactly.
My bad. That was wrong. Jeff, are you gonna shake me? I shake teachers.
I'll shave if the average on the test is
No, you just shaved tonight.
better than.
But it didn't say.
Better than 99%. If we all
The average
pass.
is above 104.
What?
Okay, I like
If
that.
the average of the test is better than 76.
I think you should
Is
shave
that a
tonight,
deal?
so I can.
Yeah.
so you can
76?
look-
I like to shave every now
I'm
and
gonna
then.
write that
Yeah,
down.
tonight.
You're what?
No, 76.
Tonight's a good day to shave.
Yeah.
Is higher than 76, he's gonna shave.
Or for the test or the quiz?
Writing this down.
On the test.
Oh,
So
okay.
that's a while. I
On the
put
actual
it
test, if we
September
get
17th. So maybe for my birthday I'll
Or
be
you have to keep them.
Baby
class
taste.
average of what?
on the test 1, September 17th.
Okay, but.
If you want the quiz, then I'll say if the quiz grade is better than 98 average.
No.
So you could do it. You could do it.
Imagine what the average has to be though for it to happen.
So I said on the test, 76, better than 76
Okay,
average. Yeah.
I'm gonna take, I'm gonna take.
98 for the quiz.
98 for the quiz.
Alright guys, come to office hours.
I need you all logged in, please.
How you guys doing? What has to happen on C, just to make sure everybody's on the right track? What do you have to do very first thing on part C?
Make it equal
12.
to 0.
Yes, you have to subtract 12.
Nice.
They kind of give it away a little bit over there.
Yeah, they,
Oh, boom.
they graph.
Already cheating.
Coming back to this real quick, did everybody saw, did okay? GCF, it's already 0, so we can start factoring. Don't start factoring unless it's actually equal to 0. The funny thing about this one is a lot of people just tell me the answer is this because they don't even think about this guy, but either that is 0, that's an answer.
Yeah.
Or x minus 6 is 0, and that leads me to this. And how does that relate to the graph? What do those end up being? X-intercepts, which only makes sense because if that is my function, setting it equal to 0 is equivalent to making y 0. And if you let y be 0, what are you going to find? X-intercepts, right? So find the x-intercepts, you make y 0. To find the y-intercepts, you make x 0.
That you do,
Say again?
that you do. Just confirm.
Negative? What? So I
Hey,
can't,
Don't listen to him.
I'm not sure what you said, I'm sorry.
Jeff,
All right.
listen to
He
this.
said nothing about you.
Oh, it didn't sound like nothing about it. All right. This guy. Has everybody factored this yet?
Yes.
You can find two numbers that worked.
Yes, sir, I did.
So x squared, it's got to be x times x. I need two numbers that do what? Multiply negative 12. Add the 4. So one of them's got to be negative, one of them's got to be positive, right? So another way to think of this, if they're different signs, they have to be 4 apart. Because what I just said makes sense. If the last number's negative, they have to be the middle term apart from each other. Yes? So of course they have to be what? Yeah, 2 and 6. So I know it's 2 and 6, and I'll catch up to you on the sign. And then of course the bigger one's got to be positive. Kick ass. And it's really easy to double check yourself, right? Just FOIL this back out, see if it comes out to be this. Just take a second and do that, right? Okay. And then of course, what two answers do I get? Yeah, we have negative 2 and negative 6. Sorry, Jeff. Positive 2. That's better. And how does that relate again to the graph? 2 and negative 6 are the y-intercepts. Yeah.
Awesome sauce.
Do you guys remember what we call this here? Vertex. Kick ass. And in this case, that would be the lowest, so maybe that's a cost function. That's the lowest cost. Profit function, you would hope it would be more like this, so you have something to shoot for. Well, that profit function would be nice, because then it just never comes back down. Oh, kick ass. Part D. What's the first step on part D?
Subtract the 11x.
Yes. So one thing I have students do is they'll do this, and then they'll freak themselves out. Because that looks wrong. And it's within the realm of something that we can do something about. Why does that look wrong? Freaking 11x is on. Let's just put it in the right place then, right? Okay. People start doing all kinds of crazy things, but if I put that in the middle, how do I factor this? Do you guys remember? Is there a GCF? Does something come out of all three?
Like multiply the last and the first and the
Yes.
Yeah.
3 times negative 4 is negative 12. So let me point something out that I did not point out before. What is the first coefficient? 1. What's 1 times negative 12? Okay, so we always do that shit. It's just when there's a 1 out front, it doesn't really mess anything up. We actually always do that first, and then we find factors of that number that add to be the middle. It only gets messed up if the first number is not a 1. So what's 3 times negative 4, negative 12? Factors of negative 12 that add to be negative 11. Yeah, people always forget about the number in 1. Yeah? How do I use those two numbers? What do they do for me? Does anyone remember? Something about the middle term.
What?
How do I use those two? You can't do this. You can't say the answer is this. That would make no sense, yes? How does that immediately make no sense?
Isn't it 3x?
Because it doesn't multiply to 4.
X times x is not 3x squared.
3x.
12 times 1 is not 4. Yeah. This thing's got a few problems, right? So,
Sorry.
but
Rewrite it as 3x squared minus 12.
yes, so these are actually the coefficients on this. Do you guys remember that? How many terms have I turned this into? 4. And what do I do when I have 4 or more terms? Grouping. Do it. Please. I'll give you a little hint on that second piece. If nothing comes out, you're wrong. What always comes out? What can you always factor out? 1. That'll help you with the next step. Maybe. Some of you guys are looking at me like, that was supposed to help us, John. So just remind you guys, grouping is 2 GCF problems, right? What comes out of the first 2 here? An x and 3, right? And what would be left then? Yeah, x minus 4. You see how that's exactly what that is? So just to make it look more like what I'm used to, I can factor a 1 out. Which sounds dumb, but is very useful. Because now how do I write the answer? Or at least the answer for factoring. 3x plus 1 times x minus. We're just undistributing the x minus 4, right? And then the actual last step is to do what now? Yeah, either this is 0 or that's 0. So this is going to lead to what answer? Can some of you guys just see what answer this is going to give me? 4. Well, that one.
Negative 1/3.
Yes, good. It's always going to have the coefficient on the bottom because that's the guy you're going to divide by at the end. Subtract 1 over, divide by 3, negative 1 over 3. If you don't like that, set each equal to 0, solve. Not a damn thing wrong with that. I just want to point out that you've done enough work already. It'd be great if you could just see, oh yeah, it's negative 1/3 and 4. If you look at the graph, Jeff, you can't see shit, man. Yes, I know. Look at the graph, there's 4, and that is negative 1/3 right there, everybody. We're just gonna assume it is. There's negative 1, there's negative 1/3 right there. Okay. Very nice. Very nice. Okay. So the most basic level of how to solve quadratic equations. And by the way, real quick, what does quad mean? Has anyone ever ridden a quad? Yeah, 4, right? So what the shit? What's the power in these equations? 2. So is anybody concerned about exactly what the people were doing when they came up with this? So here's what they did. if you draw a square, x on a side, what's its area? A square. Every side is x. What's the area?
X squared.
X squared. How many sides does a square have? Okay, that's the crazy shit they connected to call this quadratics. To be really, really honest, a lot of what we're doing is related to, like if I knew the area was one of these things, x squared minus 6x, then this could be x and this could be x minus 6, or vice versa, because it should be smaller over there, but you get the idea. So it's related to sides of a quadrilateral to make the area. So that's kind of the problem they were working with while they were coming up with some of the stuff. So that's where the word quadratic comes in. Four-sided figures that bled into this. Okay. Understandably, it's weird when you're like, it's got a second degree in the damn thing. Well, how many answers do we keep getting, by the way?
Those.
2. And you guys remember that weird, did I show you the video where the guy lifted it up and it was all colorful? Yes? Yes. Do you remember the fundamental theorem of algebra? A lot of information came at you. Yes? But there was one there that said the fundamental theorem of algebra. Here is what it is. You expect as many answers as the highest degree in the polynomial equation you're working with. Polynomial. Let me have a polynomial question. So let me show you. Let me make an equation up. Watch this, guys. Watch this. What if I had x cubed, everybody excited? Minus, what do you got, Jeff? 11x squared plus 30x. How many answers would I expect to come out of this? 3. So very quickly, does everybody see a GCF? X. And then we'll put x squared minus 11x plus 30. What two numbers multiplied by 30 add to be negative 11? I'm doing this a little fast, but it's the same shit we've been doing, right? So what two numbers multiply by 30?
6 and 5.
Yeah, 6 and 5. So then what are my answers?
0.
0,
6 and 5.
6, 5. 3 answers. Now, what about this? What you got, Jeff? Just to show you how it seems like this thing gets broken, but not really. How many answers do we expect? 2. How do you factor this? What two numbers that multiply by 9 had to be 6? Negative 3? Negative 3? What do I get? 3, or x equals 3. Now we're human. We're not going to write that again. You're not going to say, who's going with you? Joe and Joe. Oh yeah, and Joe's going with me. Like, are they 3 different people then? You need to be telling me the last names. You guys kind of. But how many answers did we get? We got 2 answers. They just happen to be the same answer, right? Couldn't 2 people have the same age? Couldn't 2, so these are 2 answers. It's just what we call, they have a multiplicity of 2. That answer shows up twice. So the official technical term is as a multiplicity of 2. So everything we did before this had a multiplicity of 1. This whole area is good. Yes.
I was gonna say, like, does that mean that vertex is on 3?
Oh, we're getting to placement of vertex and how to find it. But yes, this would essentially be a parabola that's been shifted over.
Yeah.
3. So we're going to talk about transformations probably tomorrow, but yeah, definitely tomorrow. Yes.
So with every answer, none of them are theoretical. It's like, it's not like that or that. It's like, both of these points exist. It just depends on which one, like, you're looking at.
Oh, I see. So the 2 answers we keep getting before this,
Yeah, so like those are both answers.
they both make the equation work.
It's not like theory, it's like these are both the answers.
Yeah, so if it's a physical situation, real quick, if I throw a ball up in the air, and I say, when is the ball 5 feet up in the air? Do you understand that could have 2 different answers?
Yes.
Because it could be 5 feet here, and then it's 5 feet again. That would come from this kind of work. I would get those 2 solutions. They would have a physical meaning. Sometimes, let me see this. If I'm standing on top of this, which I'm not going to do, and I throw a ball, isn't it going to go further and come down? Yes? So. Stay with me. Because it gets really interesting when a math gives us, damn it, Jeff. Okay. If I'm standing on this and I throw a ball, it can go like that to the floor, yes? Math says this makes sense. So if I solve the equation, when is it equal 0, where 0 is the floor, math will come up with a negative time as an answer. You guys understand that? Because it will say this equation goes to here. We say, math, thanks, man. But we don't have that capability. We're going to just discount that. So there will be times when, because of the physical restraints, math gives us more numbers that work, and we say that number can't be used because it would represent negative shed length. I love that when a student would turn that in. I'm like, build that for me, and I'm never going to go there because I don't know what's going to happen to me. What material do you make shed out of that has a negative side length? But have you guys ever done that in algebra where you say Sally ate negative 5 peaches? And you're like, what the hell happened to Sally? Somebody pumped peaches out of Sally. That's weird. All right.
Slaughterhouse 5 shit.
Yes. When did it happen? Did it happen? Did I undo the eating? I don't know.
And so it goes.
And so it goes. All right. Okay. So before we get to this, I'm not even going to show you that. That's not anywhere near. What I need to do is show you a process. Yes. Let's start off with this. How would you solve this? Let's solve this the long way, and then I'll show you the shortcut. Yes, but let me show you the long way. If you subtract 9, factor, I get 2 answers, yes? Is everybody cool with that? That poor little 3 got a little, he's wearing a cap. Leave him alone. But Damien said, shit's wrong with you, man. Just take a square root. Now, here's the mistake students make. They'll take a square root and they'll solve me 3. Now, obviously, that's a mistake, correct? Because we know the answer is supposed to be 3 and negative 3. So we got to cover our ass for the fact that we're doing sort of a shortcut. And to be really honest, do you guys, I'm almost certain I've told you this. Do you guys remember what the square root of x squared is? Or do you know what the square root of x squared is? It's not x.
Plus or minus with x.
Nope. Yeah, that works, but it doesn't get us anywhere. It's the absolute value of x. Do you guys remember that? Pretty sure we talked about that.
Yeah, we did.
Because the square root has to be positive. Is everybody with me on that? In fact, the square root is the principal root. How many roots of 9 are there? 2. 3, negative 3. What is the square root of 9 means what is the positive root of 9. So when I see the square root symbol, we have chosen that to be the positive root of 9. Yes? Or of whatever. So when you take a square root in solving something, you must put plus or minus immediately to cover your ass. Exactly. Or else you become FUBAR. Yes. So, does that sound familiar to anybody? Do you guys remember doing that kind of thing? And you can see how it matches now. We get both answers that we're supposed to get. Because the reality is, the square root of x squared, just to really push this too far, is absolute value of x. Now this is kind of silly. What do I take the absolute value of to get 3? What do I take the absolute value of to get 3? 3 or negative 3. So that's the long way to do it. Shortcut is just put plus or minus to cover your ass. Okay. Yes?
When you're doing the shortcut, can I just write plus or minus on the answer and not on the root?
Oh! I normally tell, if you don't put it here, but you put it there, that's fine. But I try to get people, the minute you put a square root, you should be in the habit of putting this down. Just to make sure you don't forget. Okay. So let me ask you this. What if I had this? Would you FOIL that out?
Square root both sides of it.
Do you see how this is beautiful? I'm not going to FOIL that shit out, subtract 16, make it 0, refactor the damn thing. That's stupid. I don't need to do all that. Because I know what to do if it was x squared equals 16. I'm going to do the same shit with this. I'm going to solve for x minus 2. And then I'm going to add 2. Do you guys get what I'm saying? Because what can I do immediately to kill the square, like you said? Because where's my variable? It's stuck inside of this stupid square, so that's the first level I want to get rid of. I want to blow the square up. So if I square root both sides, I immediately put plus or minus. So help me out. Sorry, Maria. It's a lot of me talking tonight. So what's the square root of 16?
Plus or minus 4.
I'm sorry. You're doing what I would be doing. I'll be staring out the door and stuff. I don't blame you.
Throwing my chocolate.
Oh, okay. Well, I'll be staring out the door, which would be even better. You guys with me so far?
Yes.
Now here's where students get tripped out. You can add 2 over and they just circle this. Or one time I actually literally had a student come up and say, where's the plus or minus button on my calculator? What does this say to do?
Either
Actually
add or
do
subtract
it.
4.
Yeah, 2 plus 4 or 2 minus 4. So you get,
6.
holy shit,
-2.
negative holy shit.
Negative.
Is that okay? And of course you can check your work like always. 6 minus 2 is 4 squared is 16. Negative 2 minus 2 is negative 4 squared is 16. Yes?
So you're saying that every time we square root a term with a variable in it, we are assuming that it's the absolute value, which is why you don't call
No,
it
no, there's no assumption. It is.
Why?
So help, again.
X is a real number.
Real quick. If I have this and x is negative 3. Let's check this out. You ready? What's negative 3 squared? 9. And what's square root of 9?
Minus 3.
No, come on. No, come on. Square root symbol tells me I've already chosen the positive root. The square root symbol is called the principal square root. So there are 2 things that square to be 9. But when I see a square root symbol, I've chosen the positive one. So what is the square root of 9? 3. If I ask you, what do I square to get 9? What do you say? 3 or negative? If I just ask you, what is the square root of 9? It's positive 3. If I want the negative one, I got to put a negative one in.
But for the other side of the term, we do plus or minus.
Because what did I do? I took a square root. How did this problem start? Like this. So they already picked the positive one. So if I have x squared equals 9 and I take a square root, I put plus or minus there, yes?
I can't see what you're
I'm
doing.
sorry.
Okay.
And that leads to, what's the square root of 9?
3.
There. Why do I put a plus or minus? Because I took a square root. If they just say, what is the square root of 16, they've already chosen the positive one, yes? If they wanted the negative one, they would have had to put a negative there.
Okay, I'm not trying to be the devil's advocate here, but the problem starts out x squared equals 9.
Yes,
So you are taking,
Yes.
I am taking the square root of x
Totally.
squared.
yes.
So why doesn't it need a plus or minus?
Because 2 things do square to become 9. This is a shortcut. And as such, we're gonna have these kind of things. And again, the long cut is either you subtract 9 over, and then you get 2 answers because you get 2 parts to this factorization, yes?
Yeah.
Or you take the square root, and the square root of x squared is the absolute value of x, which leads to 3 or negative 3.
But you're the one taking the square root of x
Totally.
squared.
I am.
And you just said that if we take the square root of something, then it's a plus or minus.
Yes, and okay. These are the 2. No, real quick. These are the 2 reasons. All right. Let me see if you're cool with this. These are the 2 long ass ways. And do you see how I did end up with plus or minus 3 both times?
Mm-hmm.
Okay. So if I want to not do all this shit and I want to do this weird shit, I can instead do like we did earlier and put plus or minus. That is shortcutting either one of these. Are you with me? This is the real way to do it. This is another real way to do it. This is a shortcut we came up with because both ways come up with plus or minus something.
Okay.
So when you take a square root, you must put a plus or minus. Why? Because that's what you get when you actually do it the whole way out.
I'm cool with that.
Okay.
But you're also taking the square root of x squared.
Totally.
I feel like we're having the same conversation 3 times.
If the problem says, what is the square root of 16?
Yeah.
they have already chosen the positive one, didn't they? There's not a negative in front.
But the problem's not saying what's the square root of x squared. You did that. The problem said
Totally.
x
So
squared
if I write, what is the square root of x squared? If I write this, yes?
Uh-huh.
I didn't take a square root. This is the problem. So what have I, so let me see, how else can I say this?
Wait, no, say that again.
This is the given problem. I didn't take a square root. This is what they gave me to work with.
Okay,
So watch, if I give you this to work with, what's the answer?
3.
If I give you this to work with, what's the answer?
-3.
There you go. I didn't take the root. They gave me this as the problem. So they've already picked the positive or the negative one.
So you're saying that if it were negative x squared, you would take the square root and the answer would be -3.
Yes,
Okay.
yes,
good.
okay.
Cool.
Now, coming back. What was I talking about? No, you're fine. Now listen. That's a beautiful, now listen, that is the heart of my job. And this is why it is so cool to have a class that feels comfortable with speaking up, because you guys have these different perspectives, which is why we need more people in mathematics, to be honest. We need new blood in mathematics to shake some shit up. But if I have a class that actually engages and asks questions, and I always am wondering if I have a quiet class that I make people feel like they can't speak up, and then always it's in my head. And I don't think I do that, but I always worry, ask whatever the shit comes to mind. Because this stuff isn't immediately obvious. There were choices made. We chose this symbol to mean the positive root. We didn't have to choose that shit. We didn't have to make this shit up. That didn't need to exist. If you ask me, I wish it didn't. I actually wish this didn't exist either, but we'll be all right. Sorry, that was too far. So, there's not a damn thing wrong with asking questions. I love it. And that's, if I didn't, I shouldn't be in this damn job. Okay. The most exciting thing to me is to have somebody ask a question on something and I'm like, I don't know how to say that a different way. And then I have to come up with a different way to say it, which is beautiful, which is, anyway, I think you made your point, Joe. So I was talking about, oh yeah, real quick. Square root of x squared. Do I still need to do this, or did I answer that question? I can't remember.
Oh, I have a question.
Yes.
So she said if you had like x, the square root of x squared, that would equal the absolute value of x, right?
Yes.
But if you put a negative in front of it, then you would just pick the negative?
If it was this, then it would be negative absolute value of x.
Well,
Oh,
that's just,
okay.
oh, you do the absolute value first and then.
And now, do you understand that this is true? Okay. If you understand that's true, then good.
But it's true by convention.
No, it's true because it's true. Are you ready?
Fuck. Damn it, I thought I had it.
What if x is -3? So this is the question, right? So there's no plus or minus because they chose a plus one. Let's leave that behind.
Okay.
Plug in -3. What's -3 squared?
9.
9. What's the square root of 9?
3.
3. Is that equal to x?
No.
Nope.
But it's equal to the absolute value.
You with me? So, exactly. What must the output of a square root be? Positive. Right? I'm talking about real numbers at the moment. Complex numbers are weird in terms of are they negative or positive. Let's not go there right now. Real numbers, the output to a square root is positive, which is why absolute value saves our ass when I don't know what the input was. Square root of x squared can't be x because x could have been negative. See, absolute value is just us covering our ass.
Oh, okay.
Okay,
So-
is that better, or that sounded like a?
That makes sense. It makes sense only if you are purposely excluding imaginary numbers. Which you
Oh. Imaginary numbers don't do that much with this, to be honest, but still, the idea of is an imaginary number negative or positive gets kind of trippy because they exist on the side of our normal number line, so it gets a little weird. Then your sense of length and so forth are a little bit stranger. Let's not go there at the moment. Okay.
No.
So, okay, give me a second. Where was I? What was I about to do?
So you were trying to solve your.
Oh, there we go. Did we finish that last?
No.
I think we're still on D.
Sort of.
Square root of 16.
quiet over there. What, no, did we finish this? Yeah, we did this one. Yeah, this is a while back. Oh, this is the one we just did, okay. Well, give me a little break, I'm sorry. We had a huge little diversion. Huge little diversion. So is everybody kind of cool with this idea?
Yes.
So if that wasn't there, then we would have stopped there, yes? X equals plus or minus 4. But since it's x minus, I have to add 2, and then I get my 2 answers. And you can double check and plug them in and make sure. Okay. This is related to what somebody said earlier about a parabola shifted. We're going to get the transformations tomorrow because that's huge. And it's something that's not in this lecture book, which is troubling, but it will be okay. I'm going to tell you guys about it. So, what if I had, let's do this. I'm going to start to number these. This is going to help me. So what if I had this? You could do it, Jeff. Can you do it, Jeff? Yes, you can. There you go. Now you could subtract 16 and factor, correct? But didn't we factor x squared minus 6x plus 9? Didn't we already factor that earlier? Sure did. And what did we get? X minus 3 squared, right? Now, do you guys understand
Okay, then.
that
I see where we're going.
that chops down a lot of the work? If you subtracted 16, you got a factor, you got a steady state. This actually kind of makes things a little bit quicker. And it's going to be even better. Well, we'll see when the numbers are not quite as nice. So this might, I'm taking a square root. So what does that mean? Plus or minus. So I get x minus 3 equals plus or minus 4.
Yes.
Add 3, so I get x is 3 plus or minus 4. So what two numbers do I get? 3 plus 4, 3 minus 4. Okay.
Yes. Awesome.
So this, let me see. This might be enough impetus to show you this method. Let's see if you guys are cool with this.
Oh, this is completing the square.
There is a number I can add here. Sort of like if that 9 wasn't there, if I add it, it becomes a nice thing to factor. Why is this a nice thing to factor? Because it's one thing squared and I can tack the square directly. I need you guys kind of with me. Let me see. If I do this on the side. It's the difference between this problem and this problem, right? I mean, it's, here I got 2 things to worry about, here I got 1, I can take a square root and then I'm basically there. So, if I can gather all my x shit into a dude squared, I can kill the squared directly. I need you to kind of see what I'm saying. Now, how the shit do we figure out what number goes here? So let's take a minute and figure this out. So everybody, I need you guys, there's a number I can add, and I would have to add it to both sides. And then this thing would factor like this. Yes? So let's investigate this. Why not? We're here. Can you guys take a minute and do that, please? Do that. And then do this. Do those 2. So this is multiplying it out, right? FOIL it out. The answer ain't x squared plus 25. So if you write that down, erase that shit. Start over. Man, tonight's nothing but me talking. Oh well. It's my favorite class, Jeff. You just talk all the time. This is not too bad. I have to write this twice. Anybody get this first one yet?
Yeah.
Write it twice, then you can FOIL it out. What do you get?
X squared.
Yeah, because you get x squared. 5x is 10x. 5 and 5 makes 25 multiplied. Somebody else working on this one? What you got?
squared minus 14x plus 49.
Yeah, x squared minus 7x minus 7x is minus 14x plus 49. Now, real quick, in both cases, where'd this number come from? Where's 25 coming from? From the beginning. 5 squared. Where's 49 coming from? Negative 7 squared. Yes? What's the middle term? More generally, double 5. Yes? So this number would be half the middle term, correct? And sure, does this matter? Does this happen here too? Half of negative 14, negative 7. So what this leads to is noticing a pattern. If I had x squared plus 8x, and I'm like, what would I have to put here so that this will factor like that? That's the question.
4 squares.
Now you see why it's called completing the square. What do I add here to make it something that can be factored like a square? So what we do is, the number that goes in the little dude is half of what the middle term is. So the first step is, cut the middle term in half. And then if I know that, then how do I get the last term? Squared. So the second term is whatever you just got, squared. That is what I have to add. That is what it becomes inside. Now this is huge, because without this process, and what kills me is they list completing the square here, and then they never talk about it, which is neat. But without this process, you can't prove quadratic formula. And I know that would kill all of you guys if you never prove quadratic formula. Don't worry, we will. So, how does this help me with anything, dear God, Jeff? Did I use both sides of all the paper? Yes. I'm done with paper. You're right. Well, let's leave. Shut. Oh, I got paper. I got one piece of paper. I got 2 pieces of paper. Look at me, I'm rich. So if I had the problem I had already, which was, what was the problem I had? X squared
Minus 4x.
minus 4x equals 11?
Something like that.
Yes.
Okay. So what are the 2 steps to figure out what to put here so that this will factor like something squared?
Yeah, with like x
Yeah,
minus
take the middle term, cut it in half. Whatever you get squared. That is what has to be added. If I add it here, I better add it here. This, the first step, is how it will factor. So you actually don't have to factor shit. The process tells you how it factors. Oh. And then, what might trip you guys up, we haven't done this yet. Isn't 15 kind of gross considering what we have to do?
We can just leave it.
Yeah, that's the tree. That's the trick. No, I'm tired, man. That's the tree.
That's the tree.
Gee, I'm a tree. I don't have to do the square root because I can't. So it just stays there. So kind of gave the game away. I'm going to take a square root now, right? Which means I got to put well, mine. Okay. So then this kills that. That's the whole purpose of it.
Yep.
Add 2. And I'm done. See, now people always hate it when it's kind of a gross number, but you should love it because that means you have actually less work to do. It just sits there looking at you. Are you guys all with me?
Yes.
Why was that such a gross answer? Because freaking 11. It's not going to be easy to make x squared minus 4x equals 11. It's got to take a freaky little number. Now, does that look like an output for a quadratic formula? I'm pushing my luck here. What time is it? Do you guys want to see the proof for a quadratic formula?
Yeah, I'm gonna guess.
Okay. Before we do that, we're going to do one more harder problem of these. I'll show you the proof of quadratic. I got a handout, and then we'll call it a day. But then we're not going to work in the handout tonight. I'm just going to give it to you, and then we're going to do it. Okay. So what if I had? What do you got, Jeff? I don't know, Jeff. What if I had 4x squared plus? You could do it. You could do it, Jeff. 20x. Oh yeah, make it gross. I like it. It's going to be really gross. Equals 7.
Yeah.
Sure. Okay.
That is gross.
That is so gross, and I love it. Now, here's the key. Completing the square is hardwired on this being a 1. So obviously, what's the first thing I want to do?
Get rid of it.
Yeah, divide by 4. So then your 7's looking even better. So I appreciate that. Alright. Now, here's the numbers are not what we wish they would be. But don't give up just because of the dumb number. We invented numbers. They do what we want. What are the steps? And this is another example. The process don't give a shit. We do, but the process don't change. What's the process? What are the 2 steps to figure out what to add here? Yeah, cut 5 in half. And then take what you just got and square it. What do you get?
2.5 squared.
No, come on, stop that. What's 5 halves squared?
10 over.
Square.
Sorry.
You're good. You gotta put a square, Jeff. There you go.
Mm.
So don't bring decimals into this shit. That makes it worse, to be honest. Do you see how that's like terms with 7/4? Which is good. Why? Because what do I do with the second dude? What's that tell me?
You add it to.
That's what I add.
I like it then.
And then, now look at that. You want to factor this? Why are we already done? How do I factor this? Come on, how do I factor? That! The first step, guys, first step tells you how this thing is going to factor. That is silly. No freaking work involved. I already did the work there. It's right there. And what's this?
It's 8.
That's even better than I thought. How's that 8? That's crazy. 32/4, isn't it? And that's 8.
Oh.
Alright, that's trippy.
Yes.
Your little 7s look at even better. That is very unexpected, but I like it. And now, let me stop. I went a little fast. Does everybody understand?
Yeah.
What do you need this first one to be before you complete the square? You need it to be a 1. So whatever the shit it is, divide by it. If I tell you to complete the square, this is what I should have done. I should have started like this, because the first thing you do is you make room. I should have started with the zeros. So whatever the hell is here, you move it out of the way, because you need room for that thing you're going to figure out you have to add. You with me? Okay, so if I tell you to complete the square, if there's any numbers, get them the hell out the way. Cut that dude in half, square, blah, blah, blah. What can I do now? You can go home, Jeff, if you'd let us. Be quiet. Your day could be done, Jeff. Now, what do I...
Square root both sides.
Square root.
Yes. Plus or minus.
Thank you.
Oh,
It's like, how long are we going to stand there like that? We'll see. All night, yeah. No. I'm going a little fast, but it's...
No, we're doing.
I mean, look at that. Look at the... Doesn't that look disgusting?
Alright.
The thing to remember, every single little step we did was not hard. But when you look at all of it together, that looks like... That's insane. Look at that. Does anyone know what you can do with this? Do you guys remember?
Just leave it like.
No.
4 and 2.
Good. Square root of 8, square root of 4 times square root of 2, which is 2 square root of 2. You gotta get used to that. And then, what's the last thing?
Subtract the 5 halves.
Subtract 5 halves. Okay. You see, do I? Do you guys want to see the quadratic formula proof tonight or next time?
I say we just.
I agree.
go over with.
I agree. Oh shit. Well, too late. I've already agreed. Let me give you this. It's got completing the square on one side. The other side's got like all the different ways to solve quadratic equations.
Thank you, sir. Thank you. I appreciate it.
Thank you.
67.
So the first thing tomorrow, I'm gonna bring a little handout that's sort of gonna act like a practice quiz in a way. A little review of, because what's the quiz covering?
Everything.
I can cover everything.
All of math.
3, 3, 3, 4, 3, 7.
Oh, I got.
So it's like behavior graphs. You could do it, Jeff. Composition of functions and inverse functions. Now, the rest of the time could be questions. If you have any questions, you can head out. If you want to get that all out of here, I will understand. But if anybody has questions, let me know. What's up?